guys, in this video we are looking at adding electrical symbols to our floor plan. Okay, so we're going to use the plan we used in the previous video, and onto that plan we're going to add electrical symbols and create circuits, as well as we'll add the panel, then panel schedules, and then add them to a sheet layout. Okay. So yeah, for part one of this tutorial, we're going to look at adding electrical symbols and creating circuits. Okay, so make sure you are using usually with AutoCAD MEP you have about 3 shortcuts. You have one for English Global, and you have English US Imperial, then you have US Metric. So you click on the one that says English Global, okay? Because well, if you're the rest of the world and you're not US, so you click this, it takes you directly to the necessary shortcuts. Otherwise, with the other options, you'll have to do so much editing of the symbols that you want to use. But with this, you have a few symbols preloaded into the tool palette. That is for the case of the electrical workspace. So this is the plan we worked on previously, so go ahead and open it, and okay, yeah, it's now loaded. Yeah, now what we're going to do is switch to the electrical workspace. Yeah, and this is what we have. Make sure you have your tool palettes loaded. We start off by adding, or we can add anything, panels or anything else, but first we need to get rid of the roof. Well, not get rid of per se, but make it hidden, and possibly the slab as well, because we no longer need them. Okay, so click on this and go to the home and freeze, okay, to disappear. Then click on the slab, same thing, go to there and freeze it, disappears. We can leave the text. We need it to know which part is which part. So now what we're going to do is to add some symbols first. We can start with the panel, there's no problem. So we have surface with a door, that is surface mounted. Surface with a well, it has a different kind of door, but not the one that swings in that direction. So in any case, you can try recessed. I always use recessed, either solid or plain or whichever. So I'll go with recessed, one that you have to dig a portion of the wall to insert. Otherwise, surface would be just placed on the surface. So along the bedroom wall, bedroom/living room wall is where I'm going to place it, or possibly along this side. So yeah, so that one is recessed. We only need one panel, and yeah, before we continue, we need to look at some naming convention that we want to use in our panel schedule. Okay, so for that you go to manage and look for the preferences panel, and then go to electrical, and what we mostly want is here the prefix, circuit naming. So circuit naming, we should use the panel name and a certain label that is like a number, okay. And or we can set other things, but usually these are the default settings, and we are good with those, like one if load reaches 80% of circuit rating, okay. You don't want to load the circuit breaker to beyond 80% of the rating, okay. It's usually a good idea to load it below that value, so that in case there's a well, that's just a concept, okay. So now we need an electrical project database, so we can create one, save it in our default location wherever we are. So I'm just going to call it, I'll give it the name that I've given to our floor plan, which is it's floor plan 01. So it's the electrical project database saves the configurations that we are using in this electrical floor plan, like the circuits, what devices we've used, and so on and so forth, okay. So number of backup files, you can leave the rest as it is. And with the voltage definitions, it depends on how many circuits you have. You have single pole circuits. We mostly work with we have one double pole, and then for the mains, then the rest are single pole circuits with a simple house design. I'm talking of global and not US standard. US will be using 120 and other voltages, but we are sticking to 230 volts for a simple residential house, okay. And then 400 volts or 415 for 3-phase, but we are not using that. So we can leave electrical definitions the way it is. These are just options that we'll choose from later on. So you can click OK. Probably before we proceed with adding other symbols, let's just define what circuits are contained within this panel. So what you're going to do is click on it, and you should be able to see properties. If you don't see the properties window, then just right click and select properties. It should be here. Okay, let me do it again. Properties. Oh, it's there. It's just a bit hidden. It's over here. Properties. Yeah. Now first we give it a name that we want. You can call it distribution panel. So just DP is okay. Then the rating for residential homes is usually 100 amps. So our voltage, so now that this is phase to neutral, we're using 230. So you can leave phase to phase like that, because actually you can just change phase to phase to 400, okay, but we won't have phase to phase. And the number of phases is 1, and we are using 3 wires. Then the mains type, now that is the main breaker, which is rated 100 amps in most consumer units or circuit or panels. So we are using an MCB. So main size is 100, design capacity, we can still use 100. Panel type, for some reason mine is not changing, but I'm supposed to use ISO. Okay, that is the because NSI is American National Standard Type, but we need the global, so it should be ISO. Okay, so most of these are not active, but maybe change this to recessed, and this is short current rating. Okay, it depends on which panel, so we're going to just leave it as blank. Okay, then feed from, this is not active, it should be active, so you can add some additional notes if you want to. All right, now okay, we can just leave it at that, and I just pressed Ctrl S to save this instance, but it's taking a while to, okay, the cursor is back on. Now what we're going to do is to create circuits. Before we add the symbols, let's just create circuits and get done with the panel. So we have like 4 spaces. We have this space, and this space, and maybe this space. Okay, so what first thing we need to identify which devices will be in this house. Obviously we have a dining and kitchen, so we need like a cooker outlet. Then we need some sockets which are not connected to the same circuit as the cooker. Then those sockets like for the microwave and fridge and so on. Then we'll have a bathroom. We should give it a different circuit breaker. Okay, for the light and maybe the shaver outlet and all that, we can just put it under one circuit. We don't need to split the sockets and the lights because this is a very simple house. We can just put them under one. Okay, we can only differentiate the wires that connect to the light, because it's usually a standard 1.5 square millimeters, and for the socket is 2.5 square millimeters, so we can always make the difference there. So living room, we can also give it just one circuit, and the bedroom also one circuit. Okay, so go ahead, click on the panel, then click circuit manager. Okay, once the panel ribbon activates, then just click circuit manager. Now under this you're going to create multiple circuits. Okay, there's this tab, create multiple circuits. Go ahead and click on it. The system type is power and lighting, and you can just call this standard system. Is a standard system. The number of 2-pole circuits, we don't have any. Those are the ones that have 2 poles, where the neutral and the live all go through the circuit breaker at the same time. But with the kind of wiring that we use with these simple residential homes, these circuits are usually 1-pole circuits. The neutral is connected directly to a certain bus bar, along with the grounding, to the grounding. So we just go with we counted how many spaces did we count? 1, 2, 3, and 4, and then an extra for the cooker outlet. Okay, an extra for the cooker outlet, and maybe an extra for the bathroom water heater. Okay, yeah, maybe we don't need a water heater for the kitchen. So those are 1, 2, 3, 4, and then 5, 6 sockets. So just make these 6 and click OK. So the names are already there by default because we set them using electrical preferences under electrical preferences. So the circuit will appear as DP-1, DP-2, like that. And now we can give it descriptions. So let's start from the kitchen part, going counterclockwise, I think, like this, kitchen, then going this side, in order not to bring confusion later on when we are assigning the circuits. So from the kitchen we start with the cooker outlet. And we can give it a 32 amp breaker. Then we go to the kitchen itself, so just call it kitchen. So we call it kitchen. I'm spelling for kitchen. And you can just give it 20, it's okay. 20 is okay. Then when we go over to the living room, yeah, we can also leave it as 20 because it has sockets and lights. Then bedroom, it will be the same thing. So living, bedroom, then bathroom, we can make it, we only have a shaver unit and some lights and a bathroom heater. So we can make it bathroom water heater. So this is bathroom like that. We can give it 16. Just make it 16 amps, and then we need water heater. So water heater, let's just call it heater. Can also give it a 16 amp breaker because this doesn't draw a lot of power. Now we can change these other ones later on. We have phases because of the type we chose. By default is set to ANSI. So we have phases A and B in reference to the American standard, but otherwise global standard should be just one phase. Okay. And the wire definitions can be changed as we do the wiring. Alright, so we can just close this. Okay. And maybe save Control S. Alright, so now let's go ahead and add some symbols. So go over here and look for power and lighting devices. Okay. Yeah. So you should have these symbols. These are the global symbols. For global standard, US symbols are a bit different. So you should know what each of these represent. Circular forehead is usually a post with foreheads. They are usually lightings for the exterior part, but we are not putting any lightings there. So what we are going to go with is go with a pendant for the living room. and a pendant for the bedroom, then use recessed for the rest. Okay, so this is the pendant for the living room. Okay, click on it and then there it is. Should try to place it in the middle, so look for midpoint, and that is the midpoint. Okay, what happened to my that midpoint? And somewhere we can just leave it there. Then bedroom, same thing, and look for the midpoint and the midpoint there. Okay, so for the kitchen we're going to use some recessed lights, the lighting panels, the 300 by 300, so that is about 30 centimeters in a square. We just need one, so we look for the middle is around there. Already place it facing this side. Kitchen, dining room, maybe we need two, so now we'll place two. Let me first disable perpendicular. Look for midpoint. So we can just put two of them. Possibly two of them here. Maybe we put one here. And another somewhere here. And for the bathroom, okay, there. And maybe for the veranda, somewhere there. Maybe for the veranda we can try using a fluorescent lighting. Just click on it and place it over there, somewhere in the middle. Okay, that is it for our lightings. So we need to add the switches for these lights. So look for, in case you're missing a few symbols, then what you do is go to manage and style manager, click style manager and browse. But before you browse, because what you're looking for is actually what you're looking for is actually hidden under program data. Now this folder on your C is usually hidden, program data or app data or program data. So what you do first is to make sure you've to make sure you are able to see hidden items. Okay, it doesn't matter which Windows you're using, you should be able to access this feature, view hidden items, and make sure it's checked. Otherwise you won't be able to see this folder as you navigate in AutoCAD. So you go to Program Data under your C and look for Autodesk, then MEP 2018 or whichever version you're using, then go in there and then look for MEP content. So what you need is under either global or US imperial or US metric. So what we need is global. So look for electrical devices. Now you should just select each and every one of these one by one as you want. Then later on do the same thing for panels. Okay, but mine are already here. So under, if in case you're missing switches, you just go to switches, electrical objects, then you click device styles. Don't click panels, but go to device. You click panels if you are interested in panels, under panels. So you choose one of these. This is three-way or a time switch, or and since I don't have an infrared switch, that is usually the motion sensor switch. So click and hold, then move and wait for the loading wheel to finish processing. When it's done, you should see something that enables you to add that switch. This is an infrared switch. We can call it a motion, well, it could be a motion sensor switch. Okay, it detects infrared and then switches on or off depending on the wiring. Then an intermediate switch is this one, a three-way switch is that one. So you do the same thing for whichever switch you want to place, and after that just just click OK. So if you go over to panels, the panels section, you should be able to do the same thing under Style Manager. Look for panels. These are global panels. Now go to electrical objects and look for panel styles. So same thing, just select whichever panel that you want. Or some of these basically look the same as viewed from the plan, but probably a little bit different in 3 dimension. So that is surface, door, floor, or whatever. You can just add that onto it and click OK. Yeah, but we are going to add some switches. So with the living room, we need to be able to so with okay, we need to be able to switch on and off from I think 3 different places. Okay, from here, here and here, the entrance. We need to be able to switch on and off these 3 lights separately. So we need 3-way switches. So we need we'll place 3 of them. I'll just have to cram them together because we don't have much space. Well, these are just symbolic, they are not actual switches. So if you add 3, then that means you have a 3-gang 3-way switch. Okay, now same thing here, you put a 3-gang. Now that is 3-gang 3-way switch. Now in order to switch from 3 locations, we need 2 sets of 3-gang 3-way switch and some intermediate switch. An intermediate switch is basically a 4-way switch. Okay, yeah, but most people confuse 3-way and 2-way. They think 2-way means 3-way, but it's a mistake. Well, actually, the normal switches that we use are all two-way switches, because you can either switch on or off, so those are only two ways. So with three-way you can switch on, off, and then there's a third in between, okay, that enables the other side to be switched on or off. That's why it's a three-way. Basically it has three terminals. Two-way has two terminals. Now same thing, four-way should have four connection points. Okay, so if you want three or more switching locations, then you need four-way switches in between. They are always in between the three-way switches if you are doing the circuitry. So you start from three-way, connect, but the four-way switches have to be in between. Okay. The switches are a little bit big in perspective in comparison to the panel and all that, but they're just symbolic, so we can just leave it the way it is. Okay. There's always a way to scale them down. We'll look at that later on, but first we place the switches. Now the switches for this area are done. For the bathroom we don't need a three-way, we just need a two-way switch. So click on whatever says single pole, and you're going to place it on this side of the wall. The switches need to be scaled down a little bit. Now for the bedroom we can put a three-way switch here, next to the entrance this side, because the door opens this side, so we put the switch here, and you can put another one here depending on where the bedroom will be. So at some point you will need to just switch off the light without having to get off the bed. So we are done with the switches. We can always try to scale them down. Oh, there's one more switch missing for this, so we definitely need to scale down the switches. We move the window a little bit further. Then for the veranda we only need a single pole, well, it can actually be part of the three-way switch assembly. Could be a three-way for gang, but then you use the other switch for just this device. So let's try to scale this down a little bit by going to edit styles. Click edit styles, and usually you're supposed to override the scale. Okay, it's a notive, then override it. Let's see if it will put a 0.5. Sometimes you can't scale it down any further. So in which case we can just not use a notive, and you press OK, then they disappear. Okay, they are not disappearing, but they are basically there, but okay, let's try now to override the scale. So that is the one. So again, style manager, so we change to maybe 10. Just put 10 throughout. 10. We need to see how big 10 is. So that is how big 10 is. So again, go back there and change it to 20 and see what 20 gives you. Okay, 20 is a little bit big, but not big enough, so change it to 50. Well, still not big enough, so we go to 100. Okay, 100 feels reasonable, I think, right? Yeah, so we should definitely go with 100. So same thing with this. I'm going to do the same thing with that switch. Instead of using a notive, go to scale override, 100. Okay, so now the switches are a bit. So same thing with this. Okay, you only need to edit one. Edit styles instead of annotation scale, just override 100, 100, 100. Okay, right. So now they look okay, not too big. So now we can try to place them close to one another to make it look like they are ganged. Okay, this might be harder than I thought. So the only other option is to, I'm going to just redo this, because let me just get rid of them and place them back again, right? Otherwise it might be harder to reposition them, but easier to add them. Okay, like that. Then we need three-way over here, another over there, then three-way here, there, and there. Then an intermediate switch here, another one there, and a third there. Then we need a single pole over here, and another single pole for the bathroom over here. Okay, so we are done with the switches, and now what we're going to do next is to add devices to the circuit. Oh, before that we need to add some sockets. We are going with twin socket outlets. Okay, or maybe we start with we can start with a shaver outlet for the bathroom. This is usually a GF CI socket. Okay, ground fault circuit interrupted socket, so that if water touches it, it will trip. Maybe we put it somewhere depending on where the bathroom mirror is. That is for the shaver. Then cooker outlet, depending on where we want our cooker to be. Let me see on the picture. The cooker is probably here or in the corner. Cooker and then fridge here. I don't know which is where, but I think I don't know. Maybe cooker here and then fridge here, or fridge here then cooker here. Okay, it doesn't matter. Let's just put it here. Then for the fridge, we just put a normal socket. Okay, somewhere here. This is for the fridge. And living room, we'll need a socket somewhere here. Actually, in most cases, we need two sockets. Depending on this, maybe we have a TV somewhere here, so we need a socket here, here, and here. So a socket here, then a socket there, and what else? We might need an extra socket here for the kitchen, somewhere here. For other things like the blender, microwave and stuff. So for the bedroom, we need a socket next to the entrance, and then we need one next to somewhere there close to that switch, and another placed, usually placed at least 3 meters apart or something. So 3 sockets should be enough to minimize the use of extensions. It's better to place enough sockets in a room. Okay, so I think that should do it. So same thing with the sockets, we're going to scale them down. So style manager, instead of using a Notive, you can try 150. Okay, so I think 150 works. It's not too big, it's not too small. Then we also scale down the shaver outlet. Instead of a Notive, we use override scale 150. Okay, then we need a water heater. So for the water heater, we have to go to it's not here. This is power and lighting. It's usually power. So what we'll do, we'll just add it and then place it somewhere here. So go to style manager, and then we are going to look for power devices, power logo, electrical, then look for device styles. So heater is what we need. You can add heater, hand dryer, hair dryer, whichever, hand dryer for the bathroom and so on, but we usually don't need a hand dryer in a residential home. We can just use a towel. So and put a heater here, water heater. And what else we need? Photocell, usually for if you have lights that should be switched on when it gets dark, mostly external lights, then you use a photocell. You can always experiment with that. So click OK, And we're going to add the symbol for the water heater. Yeah, and then we have to scale it down. So we have a bathtub, but we need to put a water heater somewhere close to it, maybe above. I think it would be above this, so we just put it there. Put it above, and same thing, we need to scale it down. We use 150. 150. Okay. The text is still huge, and how is that possible? First delete it and place it again. Oh, text is still huge. Okay, that is weird. Usually it doesn't work like that. Let me try to see what the problem is under Style Manager. Okay, design rules, connector, display properties. Okay, there's nothing here concerning the text. Text height. Text height is still a native. Should use 150, I think. That's where the problem was. See if this does it. Yeah, that was the problem. We needed to change the text as well. Okay, so now we have everything we need. Now what we do next is to add each and every one of these to the various circuits, okay, that we created with our circuit, in our panel. So we start with this. Before we do that, we need to try and give it a maximum. Yeah, we should try to give it wattage. We need to determine the wattage. So actually it's not under properties but circuit properties. Click on it, then click circuit properties. Now it doesn't matter which load phase 1, load phase 2, it doesn't matter, just choose one. And so this is for an electric range cooker. They're usually rated 100 and 1200 watts, or 1500, all the way to 2500. So we can give it a maximum of, or 2500 watts should be equivalent to, let's try the computation, to 500 divide by 230 volts. Well, that is about 10 amps. But we usually give, it's probably bigger than that. Okay, you can always just Google that. Probably bigger, depending on the rating of the cooker that you want to use. Let's just use a random value of 2500. Okay, we got 2500 watts. So, and we assign it a circuit. So under DP, it's the first circuit, DP1, the one we labeled cooker outlet. Then, if I remember correctly, the water heater was it was the last one, and we can give it maybe 1500 per. Okay. Now for the lights, we give them 100 watts or 100 var. So just make sure they are the same. So click that one, click pendant. Mostly now we use LED bulbs, light energy, saving bulbs, and they are not up to 100 watts. But the standard lamp used to be 100 watts, so we just keep it traditional, 100 watts. So select a few and then click select similar to select them all, then change the property at once. Okay, just the wattage. So just put 100, click OK. Then before we assign sockets for them, click the sockets and maybe the shaver unit, then click select similar to change properties for each device there. We're going to give a maximum of maybe 800 watts. Well, of course, for the fridge and microwave might use more than that, so but either way the breaker size is still big enough. Click OK, escape. Okay, now let's assign them to the various. We don't need to assign wattage for the switches. So for the rest, this is for the kitchen, dining, it was number 2. So select the lights and maybe the first 2 switches, switch 1 and switch 2, and same thing here, switch 1, switch 2, and same thing here. I select switch 1 and switch 2 from that side, and we are assigning that to it to this one, circuit number 2. Click OK. Okay, so now for the living room, we start with the 3rd switch, then this light, the socket, also here the 3rd switch, then this socket, and the 3rd switch here, then the 1st switch here for the porch, and we assign them to circuit number 3. Okay. Now for the bedroom, this light, socket, switch, socket and switch and socket. Okay, so we assign them to circuit number 4. Okay, hit escape, and then lastly the bathroom, we have that switch, the shaver unit and the light. We don't need to assign the water heater because it's already given its own circuit. Okay. Alright, so yeah, now at this point we can try to preview the panel schedule and see what we have. Or just go to click the circuit manager and see that the loads have been assigned, but we haven't put the wiring and all that, but the loads have been assigned, and we can view the power total amps, okay, and the total kVA. Okay, yeah, so at that point you can also try to preview the panel schedule and see how it will appear. Click annotate, then panel schedules, and you can select panel schedule. You're using you don't have to edit anything here. Okay, current drawing, yeah, okay, it's getting information from the project database. So click there. So this is how your panel schedule would appear. Of course, you can always change the text color to, you can change the color to maybe white or black, depending on so white becomes black. Okay, but in this model space we can now see it clearly. We have this our panel schedule looks like. So we need to define the cables when we've done the wiring. Okay, total load installed is there, 6.6 kilowatt. Then the circuits description and all that. Okay, we are missing service, this part, panel reference number, location, and then feed from. Okay, this is information you can just add with the text tool. Can add a number of ways are there. Okay, but we will put this later on after we've added the wires. Okay, so you can go ahead and delete that. So in the next video we are going to cover the wiring. Okay, so that's all.